Alright, so hi guys. So I wanted to go over this type of problem. It's a problem in calculus, I think calculus 1. And it's over differentiability of a function. And they want to know what the values of a and b are that make the function differentiable at x equals 2. So it says determine values of a and b that make the function differentiable at x equals 2. By the way, guys, happy Thanksgiving. I hope everybody had a happy Thanksgiving. It was like probably 2 days ago. Yeah, I'm sorry for the lack of uploads. I've been so busy. But we're going to go ahead and get started with this. Now, here's the thing, guys. Since the functions are both, since there's a, basically it's a continuous function. And how do I know that? Because obviously we have something here as well as something over here, right? And usually, we want to try and go ahead and, because in order for a function to be differentiable, so a function must be continuous in order to be differentiable. Okay, so we must remember that, guys, because this looks like a piecewise function, but since they're saying that and I forgot to add something, guys. Give me a second, hold on. Okay, guys, so given that the piecewise function is continuous at x equals 2, determine values of a and b that make the function differentiable at x equals 2. I hope I worded it correctly. I'm not sure if they worded it a little bit different, but usually what you have to understand is that it has to be continuous. Like I said, it must be continuous in order for it to be differentiable. So how do we do this, right? First and foremost, we have to go ahead and make 2ax, so 2ax plus 10 equal to bx squared minus 4x plus 9 at x equals 2. So this is a pretty straightforward question, guys. I mean, if you think about it, think about it. Like, if we have a function, let's say something like this, right? And I don't know, let's say the first one is a linear function, and we know that if I have like a coordinate plane or whatever, I'm gonna say that the function itself, let's say it's actually since it has a slope of 2, so we're gonna go ahead and just kind of make a line here. So, and I know that in this case it's right here at x equals 2. And another thing is that so it's 2ax plus 10 basically. So we know that this function, right, it's a linear function going through x equals 2. So really it kind of looks something like that, right? And then over here, right, if we look at this function here, it's such that x is greater than 2. So we would again draw an open circle and just kind of it's not, of course this wouldn't be drawn correctly, but it's a parabola basically is what I'm trying to get at. And this is supposed to be 9 over here, my bad, guys. So this is what I'm talking about, guys. Because it is continuous, there's no, like, I mean, even though there's a hole right here, it's still defined for x equals 2. So you know, when it's defined for every value, it's continuous, right? That's kind of what I'm trying to say here. And because of this, we know that if this function represents if this function represents 2ax plus 10, 2ax plus 10, such that x is less than or equal to 2, and this function represents, it represents, how do I do this? The function bx squared minus 4x plus 9. Let me write it a little bigger. Such that x is greater than 2, then we know that if this function is continuous, then 2ax plus 10 must be equal to bx squared minus 4x plus 9 at x equals 2. Okay, so in this case, let x equal 2, and actually we're going to do it this way. Let x equal 2 and let 2ax plus 10 equal bx squared minus 4x plus 9. Okay, guys, and so this is what I'm talking about, right? I know I hope I'm not over explaining it, but all you're really going to do is just make these equal to each other, plug in the x value, and solve for a and b. I do think that this might give you, and actually, never mind, no it won't. It won't give you a quadratic equation type stuff. So we're gonna go ahead and do this. So equals bx squared minus 4x plus 9, and again x equals 2, right? So we know that x equals 2, right? So we're gonna just plug that in here. So in other words, x equals 2. So it's gonna go 2a times 2 plus 10 equals, let me think here, 2a times 2 plus 10 equals, give me a second, guys, I'm sorry, equals b times 2 squared minus 4 times 2 plus 9. I also forgot to mention, and I don't know if, give me a second, guys, I'm sorry, hold on. So this one is a little tricky, guys. It has to be continuous in order for it to be differentiable. Here's the thing, guys. We want to figure out, and I did forget to do this, but you want to know that this is differentiable at x equals 2, okay? Here's the thing, you need to find the derivative, because this is the only other way we can do this, with respect to x, right? So we would say 2a, and I believe it would be 2a, I'm sorry, hold on, 2a is equal to 2bx minus 4. So you want to find derivative and use x equal 2. And then what you're going to do, guys, by the way, is we're going to go ahead and say 2a equals 2b times 2, right? So this is I will admit, guys, this is a hard one, minus 4. So you want to remember that because it's differentiable, guys, we can find the derivative of both sides and then plug the x equal 2 in for the x value. So then we get 2a equals 4b minus 4. And then, since, I guess we're going to do a systems of equations, guys, over here. Here's another thing. We also need to plug in x equal 2 to this one. To get equation in terms of a and b. Okay, so we're going to do that. So 2a times 2. So at x equals 2, we have we're going to have the following. And actually, I'm sorry, guys. Hold on, guys. I'm sorry. Okay, guys, I'm sorry about that. So we have 2a times 2. Let me think here. 2a times 2 plus 10 equals, and we're using, by the way, we're using this formula, guys, equals b times 2 squared. So again, and this one's actually harder than I thought it was going to be because it was a little tricky. We have to use the idea that it's differentiable, guys. So not only do we just use that it's continuous, we have to use the fact that it's differentiable to kind of set up a system. At least that's what I think we're going to do. Plus 9. And so then we have 4a plus 10 equals 4b minus 8 plus 9, right? So 4a plus 10 equals 4b plus 1. And now we just get it, we just kind of get rid of the constants. So we get minus 10 on both sides, right? We get 4a equals 4b minus 9, and then we're gonna just subtract 4b on both sides. So we're gonna go ahead and do that. So again, we want to kind of set it up as a system, guys. So set up. So basically, if you give me a second, we're just gonna. So now we're gonna set this up as a system of equations. So set up a systems of equations. And solve using, maybe using substitution or elimination. Okay, guys, so in other words, we have these two, so now we have a systems of 2 linear equations and 2 unknowns. So in this case, we have 2a, so the first one we have here is 2a equals 4b minus 4, so 2a equals 4b minus 4. And then we have this one, which again, it's 4a minus 4b equals negative 9. And again, guys, it's over here, guys. So yeah, we see that these are the 2 equations that we're solving. So since we already solved, since we're almost solving for a on one of them, we're just gonna solve for a. Okay. So solve for a. Okay, so 2a equals 4b minus 4. Okay. And I'm sorry guys, hold on. So we're gonna go ahead and divide both sides by 2. Okay. So divide by 2 on both sides. We get a equals 2b minus 2. So we know that this is what we're going to plug in for this here. So we get 4, so it's going to go 4 times the quantity 2b minus 2 minus 4b equals negative 9. And then we get 8b minus minus 8 equals, minus, and then minus 4b, excuse me. Keep messing up here. I'm sorry guys, hold on. So just combining like terms, we get 4b minus 8 equals negative 9. So solve for b. Okay, so add 8 to both sides. We get 4b is negative 1. Okay. Divide by 4 on both sides. We get b is negative 1/4. Now, finally, we're just going to put that in for this. So a equals 2 times negative 1/4 minus 2, which this is going to be a equals, and if you kind of do the math here, it's negative 1/2 minus 2. And then if we just get the common denominator, we get negative 1 minus 4 all over 2, which is negative 5/2. So then, thus, a equals negative 5/2, b equals negative 1/4, and piecewise function is the following, and we're just going to finish it off by describing the piecewise function. It's going to be it is going to be 2, so let me just write it out guys, hold on. Actually, since we just wanted to find a and b, that would be it. So a would be negative 5/2, b is negative 1/4. So that is going to be it for this video guys. I know this was a long one, kind of long, because we kind of had to use the idea of differentiability as well as continuity to determine the values of a and b given a piecewise defined function that is actually continuous at a specific x value. So with that being said guys, thank y'all so much for watching, and again I hope everybody had a great Thanksgiving. And if you have any questions, please let me know, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.